Electricity. The first thing we must know about electricity is what electric charges are. We know that matter is made of atoms, like this one. In this atom, we can see different particles. Three types of particles. Protons that contain positive charge, electrons that contain negative charge, and neutrons that contain no charge, so they are neutral. They don't have any type of charge. Protons and neutrons are fixed to the nucleus. Here we can see protons and neutrons. And electrons are here, moving, and they can jump from one atom to another. As we can see here, electrons are moving, and sometimes they jump from one atom to another. But really, an atom is not like a planet with a lot of balls turning around. No, electrons are really in clouds. They are not exactly in any determinate point, but they just make up some kinds of clouds that are called orbitals. So we cannot say where exactly is an electron. Well, we know that charges have forces between them. Charges with different signs attract each other. So a positive charge and a negative charge tend to attract each other, to get closer one from the other. Charges with the same sign, on the other hand, repel each other. They try to separate themselves. Okay? Well, what is electric current? Electric current is the flow of electrons along a conductor material. We can see that electrons can move along a material that is usually a metallic material. Electrons can flow along electric conductors, especially metals, copper, aluminum, gold, silver, etc. The best conductor is silver, but it is too expensive, so the most used metal for wires is copper. On the other hand, electrons cannot move along electric isolators or insulators, such as plastics, wood, wool, stone, etc. Static electricity. As electrons cannot move along isolators, they accumulate, producing charged bodies. For example, if we have balloons and we rub them, they can get charged with electrons that cannot move, so they repel each other. Or sometimes a balloon can be charged with negative charge and another one with positive charge. So they attract each other. Sometimes, if the amount of accumulated charges is very high, then a spark or lightning jumps between the bodies, even through isolator materials. For example, sometimes we see that when we touch or we get close to some metallic material, there is a spark. That's because the charges that we have accumulated or the metal has accumulated try to jump through the air, which is isolator. And sometimes this can happen when the air is charged. Sometimes these charges jump from a cloud to the ground, and so a lightning appears. What's the origin of the word electricity? Amber is a natural plastic, a solidified resin like this that was already known a lot of centuries ago. So the ancient Greek observed that when amber is dropped, it can attract small objects. This was the first known electric phenomenon that was known by human beings. Amber, in Greek language, is called electron, and this is why we call electricity electrical circuits. Electrical circuits are paths made of conducting materials. Electrons flow along electric circuits, like this. You can see that if we have a cell, an electric cell, the electrons can move from the negative pole to the positive pole. If the path is closed, is connected, if this switch is connected, then it flows. Otherwise, it doesn't flow and the bulb doesn't work. Electrical circuits have different components. Okay, different types of components. Generators, just the batteries, photovoltaic cells, alternators, receptors like lamps, motors, resistors, control devices such as switches, push buttons, protection devices such as fuses and circuit breakers, and wires that are conductors covered by isolating material. Let's explain each one of these components one by one. First, generators. They transform other types of energy into electric energy. So, batteries is one example. They transform chemical energy into electric energy. For example, we have an electric cell or a car battery. Those are generators, but there are other types of generators like alternators. They are a device, and when it turns, we make it turn, it produces electric energy. So they turn kinetic energy, which is movement, into electric energy. This is used in cars. In cars, we have an alternator to charge the battery. We also have wind turbines that you surely have seen in the fields. They turn wind movement into electric energy. So the same, kinetic energy into electric energy. And we have solar cells also that we know when sun beams into them, they turn that solar energy, the energy of light, into electric energy. Other components, receptors. They are the contrary, the opposite of generators. They transform electric energy into other types of energy. Examples, lamps. They transform electricity into light, which is a type of energy, luminous energy. Electric motors. They transform electricity into movement, kinetic, which is kinetic energy. Resistors. Resistors transform electricity into heat, which is also a kind of energy, thermal energy. Other types of components. Control devices. They handle the circuit. We can handle a circuit and make it work the way we want by using them. Examples, a switch. A switch is a device that opens or closes a circuit. You can see it here. As you see, when the switch is open, the current doesn't flow. There is no electricity, and the lamp switches off, turns off. But when it is connected, the circuit is closed. If the circuit is opened, the circuit doesn't work. If it's closed, then it works. Another example of control devices is the three-way switch, which in Spanish we call conmutador. It selects one or more from two paths. What happens when I push it? Sometimes the electricity comes from here and goes this way or goes this way, according to what I push on this side or in the other side. It's the red light which will light or the green light. We also have a push button, works like this. When I press it, the current flows, but when I release it, so I lose the pressure, then it switches off. It doesn't keep closed all the time, just when you press it. Other components are protection devices. What are they? They protect circuits from high currents. For example, a fuse. They are capsules with a very thin wire here inside. They melt if the current is too high, and so they protect other components. Let's see. In this case, we have a circuit. When we close the switch, the current flows, but very little. If we grow up the voltage, you see there is more and more current. And when it's too high, the fuse melts, and so the lamp is protected. Other components, other protection devices are circuit breakers. They are devices that switch off when they detect a high current. That's what we can see in our houses. When there is too much power, sometimes the light goes off because the circuit breaker has switched off. Another type of components is what we call the wires. They connect the other components, one with each other. This is a wire. It's got a conductor material inside that is usually copper because it's a very good conductor. But it is covered by an isolating material, usually plastic, so that electricity can't go out from the wire.